Hello everyone. So today we are going to solve a numerical problem which is related to the well testing. So basically we are trying to solve a numerical problem which involve permeability and the steady state flow equation. So we know this whenever the reservoir fluid flow through the reservoir, then uh, it is controlled by the permeability of the reservoir. So let's start reading this problem. So a well is producing oil at the rate of 800 barrels a day with the bottom hole pressure of 850 psi from the reservoir with very strong water drive. So there's a very strong water drive, so we will assume that our flow will be steady state. So what is the improved permeability? If a pressure drawdown analysis indicate that the delta P skin is at this rate is 150 psi. So basically the data is given to the objective of this question is to find the improved permeability, and we are also given with this factor that the after analysis we have found that the delta P skin would be 150 psi. So I hope so you can understand what this factor is showing here. This is showing that if due to skin factor we are reducing the pressure is 150 psi pressure is reducing. So we will discuss this factor in later video. Okay, so what else we are given with the well spacing? The reservoir well radius, which is 6.5 inches, viscosity of oil formation volume factor, the height of the reservoir, and we have the pressure, the average pressure, which is 1350 psi. So before jumping into the numerical, we need to understand few things. So this is the basic Darcy equation, but for a hemispherical geometry, it turns into this factor. So you can see this flow rate is directly proportional to the permeability of the reservoir and inversely proportional to the viscosity of the fluid, and also directly proportional to the delta P and inversely proportional to the radius. So for our case we are talking about improved permeability. So to find the improved permeability and improved flow rate, we have to incorporate this factor delta P skin. So basically if we also minus this factor into our delta P, then we can find the improved permeability and improved flow rate. So as we know, in this question we need to find the improved permeability, so we can just shuffle this equation a bit and transfer all the factors there here and make a new make subject this factor. So this is the equation we will actually going to be used. So let's see its solution. So first we are given with well radius in inches. Yes, it is 6.5 inches. We need to convert this into feet. So we can simply divide this with 12 and multiply with 2. So we can get the radius of the well in feet, which is 0.27 feet. And again we have the now we need to find the radius of the whole reservoir. To find this, we are given with the area well spacing, which is 40 acres. So first we need to convert this acre into feet square, then we need to convert this feet square of areas into radius. So this is basically a simple formula which is converting area into radius. Then we are given with the average reservoir pressure 1350 psi. Now we calculate the improved permeability. We will use this equation as we discussed earlier in the previous slide. So we just shuffle everything and this is the new formula, improved permeability. We will just put all the values here. See, the flow rate is 800 barrels. The oil viscosity is 2 cp, then the formation volume factor, which is 1.255 reservoir barrel per standard per STB, and then logarithm as it is the radius of our reservoir divided by the radius of our well, both in feeds. Then this vector, this is basically a conversion factor which is incorporating all the units together. Then we have the height. The So previously I mistakenly told that this is the height of the well, but this is basically the height of our formation, which is 45 feet. So we put it here. And then these three factors: the reservoir pressure, the well, bottom hole pressure, and then we have this skin factor here, pressure due to skin. So we will simply just put them here and solve them, and we will get this answer: 124.83 millidarcy. So this is the improved permeability. That's it.